Hey, good morning, guys. Today I want to kind of take a step back. Yesterday we had a lot of information on exponential functions. So today we're going to kind of take a step back and look at a couple things that we talked about, a couple things that I want to clear up on our exponential functions. So the two things that I'm going to be looking at today is our a value and what that actually is doing, and then whether or not we have growth or decay. Those are the couple things that I want to make sure we're looking at. Okay. Yesterday we talked about our a value is our initial value. So it's where this thing kind of starts off. What we would see this as, and what you guys have seen in the past, this is like our Y-intercept. And this also determines whether or not our graph is going to be facing up or facing down. So basically if it's flips, which way it flips. So if it flips upside down, so positive, it's going up. And then negative, it's going to be reversed to where the whole thing is going down. And you'll see what I'm talking about. It'll flip it over the x-axis. So instead of being up on top, the negative now will flip it all the way down. It's different than growth or decay, which is what we're going to talk about here in a minute. This is just saying, is it going to be above the x-axis or below the x-axis? And that's kind of what that's talking about. Okay. The growth or decay is the other part that I want to talk about. Our growth or decay is from our b value. So from b. If b is, if b is bigger than 1, so if b is bigger than 1, then our graph is going to be increasing or going up, okay? If smaller than 1, forgot the S. Is smaller than 1, then this thing's going to be going curved down. Okay. So if b is smaller than 1, it's still going to be bigger than 0, but basically if it's a decimal, it's going to be, instead of kind of this curve up, it's going to look like our second graph here where it's curving down. Okay. There is a difference between our b being smaller than 1 and our a value being negative. Our a value being negative, again, flips it over the x-axis, so it'll be down here. In this case, when b is smaller than 1, it's still above the x-axis, but it's got that kind of decreasing slope that you guys can kind of see there. So a couple things I want to look at. If I give you a problem, I want to be able to, like an actual function, I want you to be able to tell me what the a value is, so where our initial starting point is, and if it's growing or if it's decreasing, if we have growth or decay. Okay. Those are the two things that I'm kind of looking for today. So we get a general idea of what our graph's going to look like. So if I said, hey, could you sketch this graph? You might not have like the perfect line of everything, but you'd be able to at least give you that starting point. If it's curved up, curved down, those type of things. Okay. So if we were given a problem, let's say, and this is our general format. A is what we're talking about up here, initial value or our y-intercept, and B is our growth or decay, and it's our kind of rate of how it's growing or decaying. Okay. So if I was given a problem, let's say it was y equals 3.25x. Okay. So again, this is what I'm going to be kind of dealing with today or talking with you today is identifying those different pieces. So here, I can tell 3 is my initial value or my y-intercept. So if you were going to just give me a sketch of this graph, I could go to 3 and I know my dot's right there. I know that's at least one of my dots. Okay. My growth rate is 0.25. So we said if it's bigger than 1, we're going to have this growth curve that's going to be going up. So I'm gradually climbing up this steep mountain. Okay. If it's smaller than 1, then we have this decay. So now I'm going down like a slip and slide. Okay. So for this, it is smaller than 1. 0.25 is smaller than 1. So I know I have decay. So it's kind of got that slip and slide look. It's going down. So again, this is a general graph. I don't know this is going to be perfect. But if I asked you to sketch it, you'd be able to say, well, this is kind of what it's going to look like. Okay? So if I ask you to sketch a graph, that's all I want you to do is give me that general look. I have an initial value. I know it's decaying. That's what I want to be able to know. Okay? We should be able to identify it just kind of by the basics of what this thing looks like. Okay? So that would be like one example. If I'm looking at another one, so if I said y is equal to, let's say, I don't know, let's go with 2, and we're going to go with, let's just go 5. Okay, so here again, this is my initial value, my y-intercept or my initial. So if I'm looking at a graph, I know up at 2 I've got my first dot. This 5, again looking at my growth or decay from B, if B is bigger than 1, 5 is definitely bigger than 1, I know I've got my graph curving up. It is a growth model. So I'd have a line going up, and I know it's growth. Okay. This is something, again, that I would make sure that we kind of know is just that A value and if it's growing or decaying. So that's from an equation. Okay. The only one I didn't deal with, and I'll show you one of these, I guess, before I go to the graph, last one with our equation. So if I have negative, let's say, 2, and we'll just go with, let's just go with 4. Okay, so I know this thing is positive 2. So we said it's positive, or not positive, it's negative 2. So positive said it's got that curve up, negative says it's going to flip the graph to the bottom. So I know now, for my graph, I'm hitting here at negative 2, and I know this thing, instead of curving like up like this, it's going to be like the opposite direction. So it's flipping that graph completely around. The 4 tells me I have growth. So if I was to do this on the top, it would look like this type of graph. Because I'm flipping this, because of the negative, it's going to flip the whole thing kind of the reverse of what we want it to be. So this is what we end up with. Okay. Again, the negative is kind of funky how it looks. You're like, hey, Mr. Schultz, that's going down. I thought you said this was growth. Yes, it's growth. The negative flips that normal growth curve completely over. So now it kind of looks like it's that reversed curve. Okay. So that's what that would look like if you have a negative. Again, that's my initial. That's why I'm at negative 2 for my first dot. And then it flipped over the x-axis, so that's why it's kind of facing downward. Okay. If I'm looking at a graph over here, and I want to identify things from a graph, this is what our quiz yesterday had. I asked you to identify the A value, and then I think I asked if it was growth or decay for the second one. I can't quite remember what the second one question was, but I know it asked you for the A value. Okay. So the A value, again, is our initial value. It's our y-intercept. So as far as finding that, all that is a single number wherever you're hitting the y-axis. So if they ask you what the A value is, for this one, A is just positive 2. It's where I hit the y-axis at 2. For our second graph down here, I would say, well, it's at 1, 2, 3, 4. So I'd say A equals 4. So our A value from a graph is really, really easy. It's just wherever we hit the y-axis. So that would be, if I was going to set up an equation, I know my equation is y equals 4 times something x. Up here it would be y equals 2 times something x. Again, that's our regular exponential function format. Okay. Now here, if I look at this graph, this curve is going up. We have a growth model here. So if it is growing, I know that this is bigger than 1. So I know this value's got to be bigger than 1. But for right now, I just want to be able to say, yep, we're dealing with growth. Okay. Whereas this model, it's going down. Okay. We have our decay. So for our decay, we know that B is smaller than 1. So I know this value is smaller than 1. So I know I have decay. So today, these are kind of the things I'm looking for. Can you identify the A value, what's the initial value? And can you identify if your graph is going to have a growth or decay from both an equation and from our graphs? Okay. Those are the things that we're going to look for today. Kind of, again, take a step back. I gave you a lot of information yesterday. So I want to make sure some of these things are a little bit clearer today. All right. I'll see you guys in just a little bit.